To recap something else that is known about the Anthropocene geologically, here's another very important older style of deposit, the PPDs, the polymer pile deposits. This is a paper, again, similarly from the Journal of Completely Bogus Articles, that shows the relationship, at least in the Willamette Valley Formation, again, taking this from fairly locally, Willamette Formation reveals the proximity of anthrosols and the metallic arthropod migration pathways, the MAMPs, and these PPD deposits. So here's a stratigraphic section. The MAMP deposits lateral, or the early valley silt, and then on top of this, in some cases, the PPD deposits, the polymer piles, the apocalypticine, Anthropocene apocalypticine boundary ash, the volcanic ash, or the big S ash, and then in the last 10,000 years or so, after deglaciation, we have seen the coming back of a very similar late valley silt that we saw earlier in the late Pleistocene or Holocene. So what is argued here, or what is actually demonstrated, is that the proximity-based correlation does not yet show a causation of the PPD deposits by the arthropods. Okay, so they are not saying that they are exactly the cause, but they strongly suggest investigation will lead to a greater understanding of the PPD genesis. So they have called for further study to understand what has developed this stratigraphy. And within that paper, in Figure 3, they paint this wonderful picture of an artist rendition, of course, or a reconstruction, geologically, on what this area looked like during the Anthropocene. And here we have this wonderful artist rendition that shows a few things here. I'll label for you. We have the early valley silt that's exposed on the surface, and then in this one location, you have the PPD deposit that is on top of, or at least adjacent to, the early valley anthrosols, early valley silt with anthrosols developed on top of them. And then, of course, if you begin to look around, you see that the artist has also speculated and added metallic arthropods, not only in the metallic arthropod migration pathway that we know of the relationship there, but also in this short mountain polymer pile deposit. We have a metallic arthropod doing some sort of bioturbation to this deposit. Then in the background, what's also common in the Willamette Valley area of Cascadia are these much older Eocene boring volcanics that are exposed in small islands and buttes even today. So here is one of those buttes, the Spencer Butte Eocene formation that is surrounded by the PPD, or adjacent to the PPD deposits in the early valley silt. Okay, so what are the current hypotheses sort of surrounding the Anthropocene in general? How does all of this tie together? Well, it's very likely that the anthrosols discussed earlier, the bioturbation of soils and degradation due to intense agriculture or searching for the Homo sapien prey, are caused by metallic arthropods. Okay, that's pretty well known by this point, or it is at least it is a very robust conclusion. Now, also, those PPD deposits that were early harvested in the early Mycocene are correlated with both of these worldwide. And this was noticed very early on as a very blatant correlation, that the anthrosols and metallic arthropods are always present near and around the PPD deposits, or the polymer pile deposits. And actually, I should use more of a kind of a layman's term. Sorry, folks, sometimes I get buried in my scientific terminology. The PPD deposits are oftentimes what are referred to as the landfill deposits, right? Yeah, okay, I should have said that earlier. The landfill deposits of the Anthropocene that led, again, that really started the industrial revolution of our Mycocene age and have gotten us to a point where we can do a lot more with the AAPGs. So here, the arthropods are also thought then to be associated with not just the PPDs, but also many other smaller types of AAPG deposits, of which I want to go over with you now, because these are relatively uncommon. You know the PPDs, or the landfill types of deposits. You know that sometimes polymer rounds on the metallic arthropods are used. But I want to review some of the other types of AAPG deposits that you depend on in your everyday life. Now, I want you to keep this question in the back of your mind. What are the arthropods doing? Okay, I mean, it is a wonderful enigma. Kids have been fascinated about these types of fossils since the discovery of these. And of course, very similar, the dinosaurs of the Mesozoic, right? We have dinosaur fanatics that are out there, but dinosaurs, they just pale in comparison to these wonderful, charismatic creatures, the metallic arthropods that rose during the Anthropocene. But we know so little of their ecology and so little of their relationship to the rest of the landscape. So we are asking those questions further and now finding that they can be related to much of what is going on and much of what we are dependent for. So I want you to keep this in the back of your mind. What are the metallic arthropods doing? While we take a look at these other AAPG style of deposits. So here, a sort of short review on AAPG deposits. Excuse me, I'll move to the side here. I know this is a very, very busy slide, lots to read here and lots to look at, but just, what all that I'm doing here in the next couple of slides is I want to review the uncommon types of AAPG deposits. So remember, those are the Anthropocene, Apocalypticene, petroleum ground deposits. Absolutely not to be confused with the American Association of Petroleum Geologists, right? That is a separate acronym, separate entity entirely. Okay, so of the AAPG deposits, what are they, first of all? Those are exclusive to this time period. They are petroleum and petroleum derivatives that are on the ground surface, deposited on the ground surface, and there's several types of these things. We've already taken a look at the PPD style of deposits, and here's another very interesting style of PPD deposit that seems to be completely made of the feet of metallic arthropods, as if they just took off their shoes and they threw them into a pile, or they threw them up into a tree alongside the highway or something. Now, then some other types that I want to exclusively look at. Now, there are several other AAPG deposits that are out there, but I specifically want to pay special attention to those where they are ecologically focused, and the hypotheses regarding the ecological origins are close to, or they have something to do with the metallic arthropods and Homo sapiens. So I'm sort of cherry picking a few of the AAPG deposits to look at to make this case that there is a very close correlation, if not causation, between these species and our species, right? Our livelihood of petroleum deposits. So two of those, the MAMP deposit, we'll take a look at those, the migration pathways, as I showed earlier in this picture, and those are used primarily in assisting us to find the MAC regions, or the metallic aggregate carbonate regions, where we find so many of these highly variable types of AAPG deposits. Now, mind you that both of these types are not nearly as useful as the PPDs once were, and that there are other styles of AAPG deposits, older styles of petroleum deposits, not necessarily AAPG, that are still useful to us. So these, I'm using just a couple of these to make my overall point here. So first of all, the MAMP, or the metallic arthropod migration pathways, sometimes known as roads in children's books, or in related to metallic arthropods. These are often illustrated as roads, this straight flat, sometimes black asphalt, sometimes pure carbonate material. So a black asphalt is made of an organic substance, a tar or a hydrocarbon derivative substance with a whole lot of aggregate material mixed in, and oftentimes a carbonate or a concrete mixed with gravels and pebbles to make a cement, or excuse me, a cement and aggregate to make a concrete. So that's why these were early on given the name metallic, because of the presence of metallic arthropods and other types of metals in the middle of the MAC regions. Metallic aggregate carbonate regions, because of that consistent material that the MAMPs and the rest of the MAC regions are made of. But the MAMPs, as shown here, they're really giant connectors or areas where they seem to point always directly into these MAC regions. So they are not incredibly useful themselves. They have disseminated types of petroleum ores. Oftentimes we find along them fossilized metallic arthropods, big ones, small ones, and some in between, that all have the polymer rounds attached to them, so we can get those. So really the value of these deposits is not in the petroleum value, but that they point us directly to the MAC regions. So the asphalt aggregate veins are useful, but they are also fairly low grade. Then some other interesting things that were noticed early on about these that I should point out is that not only do these aggregate asphalt veins or the migration pathways in all of their chemistries, not only do they point towards the cities, but almost always along these are found these very unusual deposits of fossilized wood or a type of tree species that had aluminum leaves or some sort of aluminum, and in some cases copper, and a little bit of silicate or ceramic material that extended outwards in very thin branches. And now they seem to be non-photosynthetic, which is really interesting. But anyway, these aluminum-veined fossilized trees tend to line the migration pathways as well. So again, if arthropods, metallic arthropods, are using these as migration pathways, there's some other species that has used that maybe as a piggyback or as an ecological niche alongside of those. But these are things that we know relatively little of. So here's an artist rendition of a metallic arthropod migration pathway. It's pretty typical. Well, again, we find them in all sizes and all shapes, different chemistries. We find types that are made of iron, all the different types of metallic arthropods. And what I want to point out here in this artist rendition is there tends to always be a direction of flow on opposite sides of the migration pathway, as if they were very extremely organized while they were on their migration. So I think that's fairly interesting as a social organism, that we would expect. Okay, now let's take a closer look at what are called the MAC regions, right? The metallic aggregate carbonate, MAC regions. These regions are very broad in many cases. Some of them can be miles in geographic extent. And then there's oftentimes a core of them where they seem the mounds are much larger. Okay, let me slow down a little bit. Again, this is, if you're not steeped in this stuff and used to looking at this, first of all, what I'm showing you here is a figure, a stratigraphic section, a trench section. So this was a carbonate mound that was exposed or dug across in the O'Driscoll and Sulfuris article of 2012 about the MAC region. Where was this? Oh, yes, this was the Franciscan MAC region stratigraphy and mapping in the Journal of Completely Bogus Articles. And I've adapted this a little bit for the Cascadian section to show that the exposure of the big ass ash. But below the Willamette Valley, these exist as well. Below the big ass ash, we have these really large sections in the southern area, in the central, and then even in the northern area, some of these really large Mac mounds. So the Mac mound is defined as the edge of the asphalt aggregate areas or the migration pathways, and they centrally lead into these gigantic mounds that are varying in size from tens of meters to areas that are nearly a kilometer in geographic extent. It's really amazing. So let's take a look at these, the Mac mounds, and overall what are referred to as the Mac regions as they're so broad. Let's individually look at the stratigraphical pieces that are here. So again, I want to remind you, why do I feel like you, as an everyday citizen, need to know about the Mac regions? Economically, the asphalt is an ore. It's a low-grade ore, but we can digest that material. It can be used as a fairly low-grade staple crop food. Is abundant and low-grade. It's disseminated polyurethane throughout the metallic arthropod genus Charos that are really common. So this region, the entire region, has disseminated polyurethane ore, and we know that. Absolutely. You identify a MAC region, you have yourself an AAPG deposit. Now, that can be an extremely enriched deposit, or it can be an extremely poorly enriched or disseminated deposit as well. We really don't know until you begin investigating those things. So it really depends on how much that MAC mound used the petroleum deposits of its time, and how much of that plastic material is still around in the MAC regions. Okay, that's why I always feel like it's important to draw these conclusions. So let's look at a few of the interpretations of these types of creatures. This artist was very excited about the Homo sapiens, so they often put in the Homo sapiens into their artist renditions, but that's neither here nor there. We can talk about that later. The largest of the types of annelids here, the giant iron-excreting annelids, and those iron-excreting annelids, as they burrowed their way through their paths, they tend to excrete an iron oxide around them, and those tubes then were very well preserved in the rock record. Then, and here's artist rendition of what those things may have looked like. Then we also have the polyurethane excreting annelids. They tend to be, on average, a lot smaller. There are some that are larger in interesting areas, but they tend to fill the same ecological niche. But clearly, the polyurethane excreting annelids had something to do with harvesting the polyurethane deposits, either from the Anthropocene itself or from some other source that we don't know of yet. So they fill the same ecological niche, but they don't seem to compete for a food source. So they were very successful, both of them. We find a lot more of them in the late Holocene, early Anthropocene deposits that are made of metals, and then a lot more of them in the late Anthropocene made of polyurethane. Then what is also very interesting are the annelids, the copper polymer excreting annelids. And there's been a lot of confusion about these and a lot of misunderstanding. Are the actual metal fibers, sometimes they're aluminum, most of the time they're copper, are those actually the annelids? Are those the fossilized remnants of these annelids? Were these also, or worms? Sorry, I should have said annelids means worms, right? Worms, yes, worms. Are the copper elements, are those actually the worms? Or do the worms also secrete and leave behind in their wake a trail of copper? And that is the most sort of supported hypothesis, is that these copper excreting or aluminum excreting worms, as they burrowed through, they excrete plastic on the outside, and then out of their back end, as they're eating whatever in front of them, they're reducing that down to the element copper or aluminum. Very, very common all over the MAC regions, particularly underground and even all the way through the mounds, okay, all through the mounds. Okay, now what is the interpretation of these? There's widely varying interpretations, just like Mima mounds or something like this, but We'll stick with some of the interpretations that, again, are helping my overall point and hypothesis here. So, a little bit self-serving. The Mac features were likely, in this interpretation, were likely tall, iron-supported sessile organisms that clustered into colonies. And they generally have little or no recoverable AAPG value. That's sort of aside, but again, remember these are disseminated ores, so sometimes we can get lucky with these materials. Now, what wasn't pointed out in the mound itself, is the iron beam supports that are here. So these are really, these aren't the same as the tubes, the iron annelid or the iron worm excretion tubes, but these seem to be massive linear traces of iron. Some paleontologists do think that was the source for the iron excretors. The reason that they were under here is they were going to these Mac mounds and harvesting those and sort of running away underground. Now, so the interpretation here is that the mound itself was a type of creature. And in this interpretation, that creature, or that organism, was an erect creature, so stood straight up, and by these iron-supported features, it was sessile in place, and that gave the predator somewhat of an advantage then to almost sort of backdoor eat these from the inside out, sort of taking their iron and moving them below. Now, if these are reconstructed, a lot of these iron supports, if these are reconstructed, here's an artist's rendition of what it's thought of these look like in their Anthropocene setting. So look at these vast colonies of Macro. This is what I mean by this. Some of these things are huge, right? This is an artist rendition of a real Mac region showing the reconstruction of these individual Mac mounds that were probably erect structures standing a couple hundred meters into the air. And you know what's amazing? Again, what is amazing to me about the Mac regions, and you may or may not know this, about the Mac regions and the Mac mounds, is that we have never found a Mac region or a Mac mound without Homo sapiens fossils, either disaggregated fossils or perfectly pristine preserved fossils all over. Okay, not just, and Homo sapiens are everywhere within these things, and it's very interesting. It is commonly interpreted because the Caros genus, all genus of the metallic arthropods have their migration pathways to these, that there's some sort of, that maybe these are a holding grounds in some way, or maybe that these features they do share some morphological similarities with the metallic arthropods, and that maybe these are in some way metallic arthropod pupa or breeding grounds or something where they take the prey, or they take the Homo sapiens and capture droves. Again, these are really large speculations and interpretations, but it is there. I've not made any of these suggestions. These are other interpretations that are already out there about the relationship of Homo sapiens to the Anthropocene. Homo sapiens, very common. Okay, now here's an artist's rendition of a Mac region of the Cascadia region. This is the Portlandia deposit in the central Willamette Valley. And what you can see here, here's again the reconstruction of a Mac region. And if you reconstruct a lot of those, you can see that the densest portion, again, where some of these may have stood a couple hundred meters into the air, and that's all surrounded by a periphery of these much more small Mac mounds, but is fairly widely disseminated around this entire area, and even on opposite sides of the two dominant rivers that flowed into this area. So this is the common interpretation and reconstruction of the Mac regions.